Okay, good morning, everybody. So we're going to go over 5.2, which is integrating, and we're going to be using logarithmic and exponential functions. So we'll start with the easier one first. Okay, so this is going to be, let's see, let me make sure I got my black marker here. Yep, we're good. Okay, so we'll start off with just the definition. And for us, integrating with exponential functions, um, for now is going to just be a rule that I'm going to give you. And then later on, when we get to the very end of this chapter, I'm going to show you a technique called U substitution. And that is where the rule actually stems from. But for now, if we wanted to integrate e raised to ax dx, all right, well, that's going to integrate to, and here's what it equals 1 over a e to the ax plus c, okay? So that's really what you have to know right now. So let me show you some examples, okay? So the first example here, all right, is going to be e. So we're going to integrate e to the 1/2 x dx, okay? So according to my rule up above, I'm going to write 1 over 1/2 e to the 1/2 x plus c. And I'm going to go ahead and simplify the very first, or the coefficient here. So that's going to give me 2e to the 1/2 x plus c. Okay? Next example is going to be the integral of 6e to the negative 3x dx. All right? Well, that's going to equal, well, I'm going to take the 6 and pull it out front. So 6 times the integral of e to the negative 3x dx. And then I'm going to apply the rule. So that's going to give me 6 times negative 1/3 e to the negative 3x plus c. And clean it up here a little bit. 6 times negative 1/3 is going to be negative 2 e to the negative 3x plus c. Okay? So if we wanted to, we could extend this idea a little bit, okay? We could actually solve for c if we wanted to, and I'm going to show you how to do that. So to evaluate the constant c, here's how you do it. Step 1, you're going to integrate, just like we did above, and evaluate. Usually, if we're dealing with x or t or something like that, usually t will equal 0. Usually, okay, that's not always the case. All right, if it's not, we will be very specific. Step 2, you want to solve for c, and then step 3, all you're going to do is just rewrite. Okay, so an easy example of that, okay, would be this previous problem right here, the negative 2e to the negative 3x plus c. So let me write out the problem again. What is it? 6 e to the negative 3x dx, okay? So if I wanted to evaluate for c here, I'm going to let t, or let's let, since the variable is x here, we'll let x equal 0, okay? So I'm still going to get the same result at the very end, all right? Negative 2 e to the negative 3x plus c, all right? Now, the thing we have to remember here is this. This is equal to dy dx. So when I integrate, I'm going to get y equals negative 2e to the negative 3x plus c, okay? And what I'm going to do is I'm going to let let x equal 0. So let me write this here. Evaluate at, and we'll do it like this. You ready? Y of 0 equals 0. Okay? So there's x. This is y. So I get 0 equals negative 2 e to the negative 3 times 0 plus c. Okay? That's going to give me 0 equals negative 2, because when you look at this, e to the 0 is going to be 1, and negative 2 times 1 is negative 2 plus c, or c equals positive 2. Then you rewrite y equals negative 2 e to the negative 3x plus 2. Okay? All right. So there's exponential functions, okay? Every single one for us right now is done the same exact way. So now I'm going to introduce you into the integral of a log. So I remember a while back we said, let me write this here. This was our power rule, okay? And we said you can apply this whenever you want. But there was a catch. X was not allowed to equal, not X. N was not allowed to equal -1, okay? Because you would end up with this right here being 1 over -1 plus 1, which would have been 1 over 0. You can't have that. So I said that's the only exception. Well, now I'm going to show you why. Because the integral of 1 over x dx is going to equal the natural log, or the natural log of the absolute value of x plus c, okay? Now, this has to be the absolute value because our domain for logs is restricted from 0 to infinity. In other words, that can't be negative. X cannot be negative, okay? All right, so let's see some easy examples here. So here's our rule. Let me erase that sign. There we go. So here's the rule. So we have the integral of 5 over 2x dx. Now what I'm going to do here is I'm going to write out my steps just so you can see what I'm doing. I'm going to separate that. I'm going to say 5 over 2 times 1 over x dx. And the reason why I did that is I'm going to pull the 5/2 out front. Okay? So now I'm going to integrate 1 over x dx. We know that turns out to be the natural log of the absolute value of x. So this is going to give me 5 over 2 ln of the absolute value of x plus a constant. Okay? All right. Let's try another one here. Let's try another one. How about the integral of x to the -1 plus x to the -2 dx? All right. Well, we're just going to go right into integration, but you got to recognize that is 1 over x. This is going to be, technically, it's 1 over x squared. So here, we're going to use the log rule that we just learned. But here, we use the power rule from the previous section, okay? So the integral of 1 over x, well, that's going to be the natural log of the absolute value of x. The integral of x to the -1, or I'm sorry, x to the -2 is going to be -1 out front times x to the -1 plus c. And what we'll do here is we'll clean it up to give me the natural log of the absolute value of x minus x to the -1 plus c. Okay? So let's just continue here. I just got about, let's see, 1, 2, 3, 4 more examples here. Okay? And these are just going to be a mix of problems. Okay? So the integral of 6e to the 2/3 x dx. Well, I'm going to rewrite it first with the 6 out front. Okay? Now I'm going to apply my exponential rule. So I get 6 times. Now you got to be careful here. This is 1 over 2/3 e to the 2/3 x plus c. Okay? So now we're going to clean it up. 6 times 3 over 2 e to the 2/3 x plus c. And last but not least, 6 divided by 2 is 2, so we get 3 times 3 is 9, e to the 2/3 x plus c. Okay? All right. Let's do the next one. This is going to be a very short video. The integral of e to the 3x minus 3 over x dx. Okay? Well, here we're going to have the exponential rule and the logarithmic rule. So when I integrate, I get 1/3 e to the 3x minus 3 ln the absolute value of x plus c. All right, so let me show you what I did here. All right, if I'm strictly looking at the integral of 3 over x, what I did is I pulled the 3 out front and made it 1 over x dx. So that's going to give me 3 ln of x, or 3 times the natural log of the absolute value of x. So that's how I got that, okay? Once you do these enough times, it gets really, really simple. All you have to do is just recognize. That's the hardest part. And how do we become better at recognizing things? We got to just practice. Excuse me. Okay. So the next one, the integral of x to the negative 2 minus x to the negative 1 plus 1 minus x plus x squared dx. Okay? So when I look at this, I'll just scan it real fast, and I notice right here, there's my natural log, because it's 1 over x. All the other ones are going to be your power rule. Okay? So this is going to equal negative x to the negative 1 minus the natural log of the absolute value of x plus x minus 1/2 x squared plus 1/3 x cubed plus c. That is literally just knowing your rules. Okay? And then we have the last example right here. Obviously, I got to put one of these in here. All right. Not as bad as what you think. Just like with derivatives, sometimes it's easier to simplify first, then go ahead and apply your calculus rules. So that's exactly what I'm going to do here. What I'm going to do is I'm going to take this numerator. All right, I'm going to take this numerator right here, and I'm going to go ahead and distribute. Okay? So that's going to give me the integral of t squared plus 3t minus t minus 3 all over t to the second power dt. All right. I'm going to group like terms. So that gives me the integral of t squared plus 2t minus 3 all over t squared dt. And I'm going to simplify. I'm going to divide each one of these terms by t squared. So that's going to give me the integral of 1 plus 2 over t minus 3 over t squared. But I'm going to write that as 3t to the negative 2 dt. So, and the reason why I did that is when I go to integrate, which I'm going to do right now, it's easier for me to see the power. That's all. So this is going to give me t plus 2 ln of the absolute value of t plus 3t to the negative 1 plus a constant. Okay? And that's it for section 5.2. All right? You got to know the rules, and just got to learn how to recognize them. How do we do that? Practice, practice, practice. If you have any questions, feel free to email me and let me know. I'll see you in the next video, which is definite integrals. It's just one additional step. You already know how to do it, trust me. So I'll see you in the next video. Bye-bye.